let's move on to the practical component of our today's session. First, we need a topic, something to look the sources for. As I have shared last time we met, the easiest way to choose your topic is to choose the technology first. So, which type of casting should we research? It can be sand casting, it can be permanent mold casting, it can be high pressure die casting, it can be investment casting, centrifugal casting, or even continuous casting. So, any preferences from you?
За витоплювальними.
Okay, so investment casting. Great. Let me. Great. So that's our huge topic, right? Investment casting has lots of materials, equipment, technological aspects, and everything else. So last time I showed you this slide. So let's pick one of the four quadrants on this slide. So equipment, materials, technology, or miscellaneous. Which one would you like to explore in depth? Any of the four. Which one do you like best?
Матеріали не легше.
Great. So materials. Let me, doesn't work like that. So we'll take materials and any particular materials specifically. So they can be pattern materials, shell materials, what else? Coatings, anything, or alloys. So which one would you prefer? Let me type them here. So pattern materials, shell, or core materials, alloys, and coatings. So, any preferences?
Давайте сплави.
Okay, so alloys for investment costing. Well, alloys is a pretty big topic too. So let's narrow it down further. What can we study for the alloys? We can study their composition. What else? Heat treatment. What else? Inclusions, gases, anything else? So microstructure, mechanical traits, and etc. So, which should we focus on? Pick. Take your pick.
Механічні властивості.
Okay, so mechanical traits of alloys used for investment costing. So we're working toward narrowing down our topic first. Great. And I think we are almost done, but first let's maybe narrow down the type of alloy. So it can be ferrous or non-ferrous. And if we are talking non-ferrous, those can be nickel base, cobalt base, copper based, and based on anything else. But I'm guessing you will choose nickel based alloys because those are the most common, at least in our city, right? So, not bad. It's still a little too broad because we don't specify a specific mechanical trait and we don't study them in relation to any other technological aspects, but still, it's not bad for now. Let's stop here and try searching something for this topic. So let's see what Google Scholar gives us. At first, I'll try just pasting the general topic we've created and see what it gives me. So what I want you to do first is exclude citations and include a custom range, for example, from 2010. It's always best to use sources published in the last 5 to 10 years, but we can get away with using anything published in the last 15 to 20 years. So here are a few sources. An investigation on mechanical and microstructural properties of porous nickel-based alloy fabricated by investment casting as an implant material. So something related to implants. Physical simulation of investment casting of nickel-based superalloy. So I don't think physical simulation will work for our topic. Recent advances in the field of nickel-based superalloys. Let's see if it gives us anything interesting. So here we see an article published in Advances in Materials Science and Engineering. It's an open access article. That's great for us because we can access it for free and we can access its full text. So here's an abstract, introduction, objectives. Yep. So, and finally some figures. So single crystal section height. Lots and lots of graphs. So let's focus on the abstract and see if it's anything we could use. So we can see that the article covers production methods, casting methods, as well as unconventional alternative procedures, novel techniques, simulations, so manufacturing effects of alloying elements, that's interesting, and physical and mechanical properties of nickel-based superalloys. That's exactly the topic we've chosen, so it seems like it might be a good source. Let's see what it says. So minor changes to compositions cause significant changes in the final products. That's good for us. And yes, so they study the effects of various alloying elements. That also seems like it can work for our topic. And okay, so extensive research on physical and mechanical properties, as well as how to improve them. Fatigue life, stress rupture, creep properties, impact ductility, strain response, stress relaxation behavior, and other traits or characteristics, properties. Great, so it seems like it can be a good source. Let's copy it into our document and it can be our first entry on our references list. Great. Let's see what else we can find. So, tensile properties and thermal stability of micrograin nickel-based superalloy turbine blades via centrifugal investment costing. Seems something interesting, and it's also pretty recent. And it's published in International Journal of Metal Casting, which also seems like a good source. And if we read the abstract, you can see that this article is not available in open access, but at least we can see the abstract and decide if it would work for us. So we can see the tensile tests and other properties. So it also seems like it could fit our topic. So, as we can see, Google Scholar is pretty good, but the trouble is that when you search for your whole topic on Google Scholar, as you can see, the titles don't always match what you need. That's why we can instead try to use labs. If you haven't heard about it, it's a recent addition to Google Scholar, and it works kind of like any chatbot you've used, but it focuses on scientific papers. So let's type our prompt. So research into mechanical traits or properties. Nickel-based alloys used for investment costing. And here we can add any specifics we want the bot to focus on. For example, in relation to heat treatment. So for example, I wanted to focus on heat treatment instead of the different composition of alloys. As I've mentioned, our topic is still pretty broad. So once you narrow it down further, these labs in Google Scholar should help you find the right articles for your narrow topic, because the standard search doesn't usually work for it. So let's see what it gives us. So microstructure and mechanical properties in as built and as cast heat treated conditions of obtained by selective laser melting. Probably effects of heat treatment on microstructure and properties of cast nickel bait. Yep. Yes. So that seems like something that could work for us. And even better, it's in open access. So great. Yes. So definitely a good source. And if so this one we've already checked through our standard search, the hardness evolution of cast and the high cycle fatigue life change of wrought nickel of traditional heat treatment. I'm not sure that would work for us because it's mostly focused on wrought metals. Yep. That seems like something that could also work for us. Let's see. Yep, heat treatment. Yes, but unfortunately, this one isn't available in open access. So that's the problem, unless we have our institutional access to these types of articles. So as you can see, Google Scholar Labs is pretty precise. So you should definitely give it a try instead of the standard Google Scholar search, because as I've mentioned, it works better for specific prompts. So if you want to focus on a specific relationship between a specific alloying element and, for example, alloy's properties, labs will work much better than the standard search. And even better, as you can see, it provides a quick summary of the source, though it's not always 100% precise. So that's one avenue for you to take to find your sources. We can use the same principle using our AI tools, but let's expand on our prompt. So find and sources on mechanical properties of nickel-based alloys used for investment casting in relation to heat treatment. I want sources published in peer-reviewed journals in the last 10 years. Provide a one-sentence summary for the main findings. Only give me articles available in open access. So what should I add to the prompt? Any ideas?
Готово.
Okay, let's try Gemini and let's try Perplexity and see which works better, or even if their results match. I've had some experience with this too. So I'm using deep thinking for both models, and we'll have to wait a little for them to work, and we'll compare their results. So Gemini seems ready. Recent research on cast nickel-based alloys and heat treatment. Effects of heat treatment on the microstructure and properties of a cast nickel-based high. Yeah, we've just seen this one, but we've been here. So analysis of microstructure and mechanical properties. Yep. Also seen it in Scholar Labs, experimental study of his casting. Let's see, it might be something interesting, but that's the problem with Gemini. It doesn't always provide direct links, but still yep, it seems something relevant. Great. The effect of heat treatment on the microstructure and mechanical properties of K418 super alloy. I'm not sure it's nickel based, to be honest. Let's see. Yep, that's something. Yeah, the link is broken, but let's try searching for DOI. Yep, wrong link. So this one is a hallucination. Optimization of the heat treatment of additively manufactured nickel-based superalloy. This one might seem interesting, but it doesn't actually match our topic because it's additively manufactured nickel-based superalloy and not cast superalloy. So this wouldn't work for us. Grain refinement of Inconel, the effect of rotating magnetic field. That doesn't match our topic either because it's not about heat treatment. And on the microstructure of, yep, well, this one might work. Let's see. Great. That's why I prefer Google Scholar because, yep, another hallucination. Well, as you see, you cannot trust even deep thinking models to give you correct links or even correct sources that match your topic. So, yep.
А якщо по назві роботи і авторам дивитись, шукати?
Let's try. So, which one was broken? This one, right? We can even try to search for it in Google Scholar to make our job easier. Let's try. Is it the one? No, the authors are different. But it is something similar, but it's published in 2005. So it's not the same article. I'm guessing it's just a hallucination. So this one doesn't exist. Probably. Well, we can also search through Google. Let me add quotation marks. Yep. It doesn't exist, I'm guessing. So yeah, I'm not telling you not to use AI models. Just be very careful. As you see, we have to check everything because it did give us a couple of links that we found through Google Scholar, and those work. So those articles match our topic, and the links actually work. But as you can see, the rest are just random hallucinations. Let's see if Perplexity did any better. So open access journal. So Shahov, I'm guessing it's a Russian journal. We should have added it to the prompt, not to use Russian-based journals still. So investment costing heat treatment versus stepped aging. Let's see if this one is something we could use. Yep. Analysis of microstructure and mechanical properties in as built as cast. Yeah, this one could work, definitely. Great. So, nickel base superalloys and gamma titanium aluminum alloys. The high temperature homogenization and well, let's see. Yep, not found. Super. We can try to search for it in a Scholar. I guess I lost it. One moment. Let's see. I think it's this one. Yeah. Well, at least it exists, just the link was broken. But it could also work for our purposes. Usually high room and elevated temperature tensile properties observed in direct 8-wire arc directed energy deposited in canal 718. Once again, as you see, it doesn't exactly match our topic because it's not for cast parts, but for wire arc directed energy deposited in canals. So it's not quite the same, but we can still check the article. Yep, here it is. So not bad, but not exactly matching our topic. And so this one is Ukrainian. Mechanical properties of heat-resistant superalloy in canal obtained by selective laser melting and heat treatment under different load directions. Once again, doesn't actually fit our topic, and the link, it has just a period at the end that doesn't work. So potentially quite useful and also by Ukrainian authors, so that's good. So influence of rejuvenation heat. Yep. Yeah. So Mm, In my experience, Perplexity is a little better about providing links to sources. But as you can see, it adds a period at the end of the link that's sometimes does makes the so that the link doesn't work. But still, it's a little better than Gemini because, as you've seen, Gemini provided just a couple of entries that just didn't exist at all. Perplexity usually provides relevant links, but still some of these articles don't match our prompt. So once again, I want to remind you to check everything and AI spits out at you. So once again, you can use any tools you like, either Gemini or Perplexity, Grok, Google Scholar Labs, anything else. But your task for the next session is to choose your topic for your research project. Once again, it can be either connected to your future thesis or not, but you need to formulate the topic. You can use this type of process like we used today. So first choose a broad topic and then slowly narrow it down. So you need a topic around up to 20 words long. Next, I want you to formulate the relevance of this topic. So explain to me why should I or anyone else care about this topic? So why is it important? Use up to 5 sentences to explain the relevance of your topic. And uh, create a list of at least 5 sources on your chosen topic. I want to highlight that you shouldn't use sources that are generic. So, for example, if you want to study, like we did today, so the influence of heat treatment on the mechanical properties of nickel-based alloys and their cast parts, do not provide a book about investment casting as your source. That's not specific enough. So your sources must be directly connected to your narrow topic. 5 sources that meet the requirements that we've covered today, so that they should be new, they should be objective, and they should be reliable. You can use, as I've mentioned, any tools we've discussed today to find those sources. And I want you to include your topic, your relevance, and the list of 5 sources in a Google Doc and provide a link with editing rights as an answer to your assignment. And it should be ready by the next week. Any questions?
Немає, все зрозуміло.